Hello everyone, welcome to solve this math Olympiad algebra problem, and here we have a square root of n plus n equals to 5, and we solve this problem for the values of n. And at the last we check the values of n and find those values of n which satisfied this equation. So here the very first step we are going to do is here first we remove this square root sign in the left hand side. So here we move this plus n to the right hand side, and it will be written as a square root of n is equals to 5 minus n. And after that, in order to remove this square root sign, we need to take the square on both of the sides, so that here we take a square on both of the sides and it will be written in this way. And after that, here we need square identity in the right hand side, and we know that if we have a minus b whole square, it is equals to a square plus b square minus 2 times of ab. So we use this nice formula to the right hand side, and in the left hand side these 2 and square root are gone by each other, and here we get n equals to so here we apply this formula, so it will be written as 5 square plus n square minus 2 times of 5 into n. And now in the next step, here we need a little bit simplifications, and we know that 5 square equals to 25, and this is our n square minus this 2 times of 5 becomes 10, and this is n. And here we move this n to the right hand side, and it will becomes here minus n, and in the left hand side we get 0. So here we rearrange the terms and we write it as, so here first we write the positive term n square, and after that we have this is minus 10n minus n is equals to minus 11n, and this is plus 25, and this whole equation equals to 0. And now you see here this equation becomes quadratic equation in n variable, so that here we use the quadratic formula in order to solve this quadratic equation. So now first we write the coefficients of this equation, and its coefficients are a equals to 1, b equals to minus 11, and c equals to 25. Okay, so these are the coefficients of the above equation, and we know about the quadratic formula. It is stated as minus b plus minus a square root of b square minus 4 times of ac divided by 2 times of a. So this is our quadratic formula, and now we substitute the values of a, b and c here. And now first we put the value of b, and the value of b is minus 11 plus minus square root of b square. So b is minus 11 square minus 4 times of a. So our a is 1 and c is 25, and this whole is divided by 2 times of a, and our a is 1. So now here we need more simplification, and this is minus times of minus becomes plus 11, and plus minus square root of minus 11 square, and we know that minus 11 square equals to 121, and 4 times of 25 is equals to 100, and this is divided by 2 times of 1 is equals to 2. So here we subtract this 121 by 100, and it is equals to 11 plus minus square root of 21. So when you subtract these two, you get here only 21, and it is divided by 2. So here we have the values of n is 11 plus minus square root of 21 is divided by 2. So that, and now we separately write both of these solutions, and here we write the positive value. It is n equals to 11 plus 21 square root divided by 2, and here we write the negative value. It is 11 minus square root of 21 and it is divided by 2. So here now first we write these two solutions in decimal form, so that when you take the square of 21 and you add it by 11, so you just get here 15.58 and it is divided by 2. And similarly in this case, when you take the square root of 11, square root of 21, and we subtract it by 11, then you obtain here 6.42. It is divided by 2. And now in the next step, we just divide these two values, and when you divide 15.58 by 2, then we get here 7.79. So this is the our solution 1 of the given equation, which is in decimal form. And similarly, when we divide these two values, then you get here n equals to 3.21, and this is the our second solution of the given equation. So here we have these two solutions, and now we check that which of these solution is satisfied our given equation. So that to verify this solution, here we just first copy down the given question statement. It is square root of n plus n equals to 5. And now we substitute both of these solutions here. Now first we verify our n1, and n1 is 7.79. so when we substitute this value here, so it will be written as in this form, 7.79 square root plus 7.79 is equals to 5. So here you clearly see that when we take the square root of this term and we add it by 7, so you cannot get this value is equals to 5. It means that the sum of these two values is not equals to 5. It means that n1 equals to 7.9 is not the solution of given equation, but n1 equals to 7.79 is extraneous root of the given equation. Okay, so this is our extraneous root. And now we check the second solution, and our second solution is n2 equals to 3.21. so now we substitute here n2 equals to 3.29 in this given equation, and we check that it is 3.21 square root and plus 3.21 equals to 5. And here you see that when you take the square root of this term and you add it by 3, then you approximately get it is equals to 5. Okay, so this solution is approximately equals to 5. It means that n2 is satisfied our given question statement, so n2 be the only solution of the given equation, but n1 be the extraneous root of the given equation. And this is the final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.